Welcome to DHSR VLM Degree College, Navarpalli. So, in this sessions, I'm going to talk about the second BSc Computer Science campus that is called Data Structures, which is comes in the fourth sem. Okay. So, in previous class, I was discussed about the sorting techniques. There is some sorting techniques are available. So, in these sorting techniques, we have discussed in this previous classes here. And now today I am going to talk about the last topic is of the fifth unit, that is named as called as a searching techniques. What is the searching techniques? Okay, so in the fifth unit we have only two techniques are available here. That is called, one is the sorting technique and second one is called as searching techniques here. So in the searching techniques we have to see what is the searching techniques here. Okay, so searching technique means we have to find the needed element. We have to find the needed element. The element will be placed in the one dimensional order. The array dimension is placed in the one dimensional order, and it is can be placed in the sequential order or non-sequential order. That means it is in the uh, sorted list or unsorted list. We have to find this the needed element here. So for this scenario, we have to find this sorting techniques. So searching techniques, yes. So we have to find the each and every node to listing of the array here. And we have to find the zero index and the first index, second, 3, 4, 5, 6, and so on here. Okay. So and we have to separate the given sorted into two parts here, and we have to find the middle element of the array here, and we have to again we have to subdivide into the again array part, and we have to find the needed element here. Okay, so searching technique means we have to find the given element. Okay, sorting technique means what here, the given sorting techniques are given in the number of elements, which is can be placed in the format of the sequential or non-sequential order here. Okay, then we have to find the needed element only. So while we are using in this sorting techniques, searching techniques, we have to find the given element in the given element to find here, and that element will be placed in the given array here. Okay, that's why we have to use this uh, searching techniques here. And searching techniques we have to divide into two parts here. So searching techniques can be categorized into two parts. First one is the linear searching technique, and second one is called as the binary searching techniques. So both are going to performing this uh, searching techniques here, and linear searching techniques going to follow the some of the rules here, and the binary searching going to perform the some of the rules here. Okay, so both are can use it to find the given element in the single or one dimensional or two dimensional arrays here. Okay, so what is linear searching? What is binary searching? Okay, I'm giving the brief explanation. Linear searching means so you have to find the given element in the array. You have to find the first element, second element, third element, up to find the needed element here. Okay, but whereas come to binary searching techniques, the binary searching techniques can be divided into two subparts here based on the middle element here. So middle element can be calculated by the using the formula we have to see in this divide and conquer rule here. That is called low value by low value plus high value by 2 here. So that is the middle value, and we have to find the given element here, and the needed element is the left side or right side here. If it is right side, we have to again divide the find the needed element here, and again if we have the element will be placed on the left side, we have to find again middle element and again go to the process here. Okay, so that is the main purpose here. And what is the difference between these two here? Okay, linear searching techniques is going to perform the sorting techniques, or searching techniques is slower here. Okay, while your binary searching is going to perform the condition is very high here, very high here. Okay, that purpose we have to the main difference of this, yes. And the linear searching can be find the given array as in the one dimensional array or two dimensional array, whatever it may be. The linear searching technique will be going here. Okay, but the binary searching, whereas come to whereas binary searching, it can follows, it can searching the element only in one dimensional arrays only, one dimensional arrays only. Okay. Next, it having the time complexity. The time complexity is O of n here, O of n here, and whereas come to binary searching techniques, log base 2 of n here. So this is the worst cases of the time complexity of the linear searching techniques and binary sorting techniques. Okay. Next, if you want to searching the elements in the linear searching elements, that given elements will be either in sorted order or unsorted order. We have to find this needed element here using this form, using this searching techniques. But whereas come to binary searching techniques, if you want to find the any element, the given array will be in the ascending order but not the descending order. Okay. But linear searching accepting both the ascending or descending, that means sorted or unsorted list will be accepted here. But whereas come to binary searching here, it will be accepted only ascending order only, that means sorted order only. Okay. Now I'm going to talk about the linear searching techniques. So what is going to perform the conditions here. Okay. So if you want to, that means if you want to prove this linear searching techniques, you have to use this some rules here. That is the element, the element are in the random order. Okay, the element in this random order, whereas come to the binary search here. Okay, so linear search is going to follow the a systematic orders, systematic order. It can follow systematic plus 1 2 3 4 5 6 and so on here. Okay, and the going to it going to linear searching techniques here. Okay, whereas come to this order we have to find this is also very accessing here. Okay, and now it is going to some taking some example. So example to sorted techniques here. So see, so what is the linear searching tells what here? Okay, so it is the sequential order. Sequential order will be follows here, and it can take the time here, the time complexity. The time clock complexity of the worst case is called as a 0 n here. Okay, and it is slower process, slower searching technique. That means compared with the linear search, linear search is going to perform the condition is very fast. Yes, because of it can then can be going to perform the random order. It can be going to in the sequential order here. Okay, that is called as a linear order here, and it can take this take sorted list, sorted list or unsorted list here. Okay, if you want to take this sorted list or unsorted list, whatever it may be, we have to take this. That may be you have to follow this rule here. That is we call as a unsorted list here, and it is also accepting both accepting accepting what's here, accepting both one dimensional and two dimensional, 1D or two dimensional arrays, array elements. Arrangements. That means the linear searching techniques can accepting either in the one dimensional order or two dimensional order. Okay, if the one dimensional order is in the shorted list or unsorted list, whatever it may be, we have to follow this rule here using this linear searching techniques. Okay, so for this example, I am giving this some example to prove this. What is the linear searching technique here? What is the linear searching technique here? Okay, the linear searching techniques to tell us about here. The linear searching techniques is it is going to sequential order. It is going to sequential order. That means it is starts from the index 0 and 1, 2, 3, 4, 5, 6 up to end of the array here. And the time complexity is the 0 of n here. 0 of n here, and it is the slower process where compared to the binary searching techniques, because of the we have to traverse from 0 index and find the needed element here. Okay, that's why the needed element will be placed at the last, and we have to find the from starting the value here and up to last will be appeared here. So that's why it is going to sometimes it's going to very slow searching techniques here. And it can take this whatever it may be, the given sorted list will be if the given list is either in the sorted list or unsorted list, whatever it may be, this may be applicable on this linear searching techniques. Okay, the linear searching technique will be going to process this algorithm here, and it accepting both one dimensional and two dimensional array of the elements here. So that's why we can accepting both one dimensional or two dimensional arrays here. Okay, so now I'm giving you some example here. So in this example I'm taking some elements here. This example I'm taking some elements here. So first we have to take this given element will be sequential order 2, 3, 4, 5, 6 here. So actually this is called as a sorted list here. So in this sorted list we have arranged the elements in the 6 elements here. So this is the one dimensional array here, and this is starts from the array index is starts from 0, 1, 2, 3, 4, 5 here. Okay. If you want to find the given element will be the 4. So our needed element will be 4. The finding element is what here 4. So I want to find this element, that is called 4 element will be placed in this array. I want to find this element using this searching techniques. So searching techniques is always going to start from the its index, that is called 0 index. Okay, so first we have to find this 0 index. Okay, if it is 0 index, 0 index does not contain the one value, so it is not possible. Next will be come to here and check the condition to satisfy. So for example, array is equal to 0. Okay, what are we? So 0 index not here, and in this scenario is also failed here. That means 2 is also failed here. Failed. Next come to 3 here. Here 2. So array index 2. In the 2 context, what here? 3 will be here. So it is also false here. So last we have to find this 3 is equal to 4. This is the our needed element here. This is the our needed element here. Okay, this element will be caught after 3 successively traversing the array elements of the here, and after the fourth element is the our needed element here. So here in this scenario we have to traverse the 4 steps here. Okay, if the needed element will be 6, we have to visiting each and every node of the every element of the given array up to 6 years. Then we have to visiting 0 location, first location, second location, third location, fourth location, fifth location. After 5 steps, we have to find your needed element here. So this is the called as a sequential order. In this sequential order, we have to find this element. So here it is not available here, and again going to here. It is not available here. Again it is going to here, and we have to go to here, and we have to find this element. So in this third location, we have to see there is a 4 element will be placed here. So this is we called as a linear searching technique here. Linear searching technique here. So in the left side, I am going to place this. Now I am going to compare with this another searching technique, that is we call as a binary searching technique here. Okay, so binary searching techniques. So binary searching technique is the one of the technique, and it is also used to find the given number here. Okay, so the linear searching techniques is going to follow this order here, and the binary searching technique is also going to perform this some rules and regulations. Yes, so we have to see it is going to sequential order here, and it is going to random order here. It is going to random order here. So why it is going to random order here, I will tell you at the explaining of the example here. Okay. Now the time complexity. Okay. The worst case of this, worst case on time complexity, whatever it may be, worst case or time complexity. Time complexity with 0 n here. So here 0 log raised to n here. So this is the worst case. Yes. So in this scenario, we have to find the given element very easily here with respect to the binary searching technique. Is the very fast technique compared with this linear searching technique here. Okay. And this is the slower searching techniques. This is the fast accessing. Fast accessing comparing with the linear searching techniques. Comparing with linear searching techniques, this is the fast accessing here. So why it is going to fast accessing will be seen in the further here. Okay, and next it is going to take the sorted list or concentrate list order it may be. If you want to perform the linear searching techniques, you have to take this array order either in the sorted or consorted here. But here you can take only sorted list only. Sorted list only. Okay. Next, accepting both the one dimensional or two dimensional arrays here. But here only accepting what is the one dimensional. Only accepting one dimensional. That is called only of array. Okay, so that is called it accepting only one dimensional arrays only it accepting here. Okay, so this is going to the random order, and we have to see the worst and time complexity is also here, and fast accessing and only sorted list here, and only accepting only one dimensional array here. And now I'm going to giving you some example here. So in this example, it is also going to perform this binary searching techniques, divide and conquer rule here. So what are maybe here? And we have to take this same element add element. So we have to see six elements. 1, 2, 3, 4, 5, 6 years, and each location 1, 2, 3, 4, 5. Okay. So in this scenario, we have to find the middle element here. So how to find the middle element here? So it is already we have to see in this divide and conquer rule. So how it is going to find the middle element? The middle element will be placed with the formula is equal to mid is equal to low plus high. That is called this is the low value here and this is the high value here. So if you want to find the given element here, so here we can find the fourth element. Here is also we can find the fourth element here. We can also find the fourth element here. Okay. So now I am going to the middle element will be middle element will take as low plus high. In the low content what here 0 plus high element 5 by 2 here and by 2 here and 5 by 2 is equal to only 2. Okay, actually 2.5 is also available here, but we did not consider the fractional part here. Okay, so this is we call as a middle element. So what is the middle element here? 2 is the middle element here. Hence we can, this is the 2 element and we can check this here. And again in this scenario, you have to find the needed element will be either placed in the left side or right side here. Okay, if the needed element will be placed as a left elements, all these left elements will be decayed here. It's removed here, the elements here. Okay, in this session left does not contain the needed element here, so that's why it is the entire left part will be deleted here, and we have to see only the 4 elements, 3 elements will be here. That is what is 4 by 6 also available here. Okay, 4 by 6 also available here. In the same case, we have to find the again the element, the middle element. Middle element is equal to O plus 5. That means 3 plus 5. That is called as 4 here. It is 3 plus 5. 3 plus 5 divided by. So So, sorry, after getting these elements, we have to see only 4, 5, 6 elements can be placed in the list. Okay, this is the zero location, first, second location. Now you have to find this. You have to find the middle element. The middle element will be found with 0 plus low plus I plus 2 by 2 here. That is the one element. So in this one element, we have to uh, connect connect the one element, and the left element will be our middle element. So directly we have to traverse this element very easily here because of the left having the only one element, that is called our hidden element here. So in this scenario, we have to find the complete element within the two steps here. The first steps will be remove the left elements, and again we have to separate this, and again we have to find the left element will be our hidden element here. So but here we have to see, first we have to see this element, and second we have to traverse this element, and thirdly we have to traverse this element, and fourth we have to visiting this element. The fourth element will be our hidden element here. So this is the, we have to, the left part will be removed here, and we have to see only three parts of the keys, and one step is zero, and second step we have to find the given element will be placed in the left side of the order here. So this is called as a shortened techniques. This is we call as a searching technique. This is called a binary searching techniques. This is called as a linear searching techniques. Okay, linear searching techniques, we have to follow the sequence order 1 0 1 2 3 4 here. But here we should not follow the any cases, because of this sometimes we have to follow the forward direction, and we have to follow the backward direction. So here we can follow the forward direction, and here we can follow the backward direction because of the fourth element will be placed in the left side here. So here the fourth element will be placed in the right side here. That's why this is called as the random access here. And the worst time complex will be 0 log 2 base log base 2 of n here. So this is the worst case of the here, worst case of the time complexity, and this is the past access compared with this index here, clear searching technique here. And it can only, it can accepting only sorted list only, and it is also accepting only in this one dimensional arrays only, but not the two dimensional arrays here. Okay, so this is the class of the binary searching techniques, and this is the class of the linear searching techniques. Okay, so this is the our syllabus of the data structures. If you have any doubts, please ask me of the entire data structures here. Okay, so in this syllabus we have to complete the first element. The first unit is called as the overview of the data structures, and second unit called as the stacks and queues. The third unit we call as the trees, and fourth unit called as a graphs, and fifth unit called as a searching and sorting techniques. Yes, and also sorting techniques are also completed in the previous classes, and today I am going to complete the searching classes. Yes. Okay, I hope that everyone can understand this class. If you having any doubts, please ask me after watching this class here. Okay, thanks for watching this class. Have a nice day, and all the best for your exams here.